My name is Dennis James, and I am the Online Course Development Manager at Edgewood College in Madison, Wisconsin. Today I'm introducing Learning is About Making Connections, written in 1999 by Pat Cross for the League of Innovation in the Community College. The schema we use in developing lessons and courses can affect when students have the aha experience of seeing connection between two formally isolated concepts. And we may only lay the groundwork for the ahas that come years later. This satisfaction is ours as faculty and the learners in our classroom. Schema is the structure in the mind where facts, ideas, and associations are organized into meaningful relationships. This structure changes, adapts, grows, and shrinks throughout our life. The cognitive connections students make with the new knowledge we share are going to differ based on their previous knowledge and experience. Or put it a different way, we all have filters. Do you recognize the concept of schemata in your development of lessons? What impacts does making cognitive connections have on faculty and faculty development, on curriculum design and development, on organizational development, and even on an individual's learning styles? What are the differences between surface and deep learning? Surface learning can be summarized by asking a simple question. If students can cram for your tests and pass them, have you created a climate for deep learning in your teachings? Looking at the strategies of rehearsal, elaboration, and organization, which strikes you as the best description of how you teach? Do you structure your curriculum so that your students construct connections and relationships between ideas? Metacognition strategies are planning, monitoring, and self-regulation. A mature learner has developed these strategies. Malcolm Knowles researched and informed us on the theories of andragogy and adult learning. From this, a set of principles and presumptions were developed that support the metacognitive strategies, even if all adult learners have the same insights. Do you provide experiential learning experiences for your students to enhance their learning? How did our ancestors learn? Would you hire a plumber who only had classroom time, or go to a doctor who did great on tests, but may have had trouble in his or her internships? Do you allow reflection time in your class? Think back to how important this was in your learning journeys. I found that reflection benefited my learning and growth, and I make sure it is included in my assignments to students. Developing a personal philosophy can have significant impact on your teaching. I've helped hundreds of faculty think this through, and nearly all came away with renewed appreciation of their craft and of how to express that to their students anew by improving on their teaching strategies. I'd like to give you an example of surface learning versus deep learning. The example I want to share is lockout-tagout, and as you can see in the screen, the consequences of surface learning only can have deadly consequences. One of the industry standards for making sure it is safe to work on a machine is OSHA standard entitled OSHA 1910-147. Typically it is called the lockout-tagout standard, and typically it is taught as a series of steps and could be considered surface learning or teaching. The standard itself is really named Control of Hazardous Energy Sources. When teaching this, a deeper understanding of the safety issues involved is covered. When working with electricity, there's dynamic and static. Plug something into a wall outlet for dynamic electricity and use a capacitor or battery for stored energy. Hydraulics and pneumatics have dynamic energy in a hydraulic pump on a log splitter or an air compressor filling a tank. Your tire has stored pneumatic energy. And then there is kinetic energy. This is what happened in the death of the UW-Madison physical plant worker in the spring of 2013. Kinetic energy is dynamic when you are moving something physically, like your car, and gravity makes a great storage unit for kinetic energy. When teaching students or employees about the control of hazardous energy sources, they begin to think of not just the process of lockout-tagout, but in terms of the energy sources that they may have to deal with. The students are tapping into previous working knowledge of the systems they are performing lockout-tagout on. How you think of teaching something can either promote deep understanding or can continue to be surface knowledge for your students. In concluding this piece, I hope you carry these thoughts into your syllabus design, your course and materials construction, your choices about activities for your students, all the way into the assessments you plan for student performance.